integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1, and this is to be used if n is not equal to minus. Okay, this is to be used if n is not equal to minus. This is actually the same rule that we had in differentiation. In fact, all the rules are the same, only reverse formula, that's it. So, for example, suppose you want to do integration of x cubed dx. Compared with this, what is that n's place? 3. So put 3 here. So x raised to 3 plus 1 upon 3 plus 1. That is x raised to 4 by 4. Got that?
Yes.
Easy to understand this part?
Yes.
Okay, you try one more on your own. Suppose you want to do integration of, let's say, 1 by x square. First of all, this 1 by, we don't like that. So you'll have to convert to x raised to something. So do that. 1 by x square means x raised to minus 2. Very good. Now we are ready to do integration. Use the rule. Compare with the formula. What is at n's place? Minus 2 is at x. So put it appropriate. Okay? Minus 2 is at n's place. Put it that way. What? Done?
Yes.
And the answer is
X raised to minus 1
upon
minus 1.
which you can simplify to minus 1 upon x. Alright? Because x raised to minus 1 is 1 upon x, and this minus 1 means negative. So minus 1. N is not equal to minus 1. So here when we compared, what was the value of n? 1 by x. Value of n by comparing these two. Minus 2. Minus 2 is n, minus 1 क्या? Minus 1. The problem will be when n is minus 1. N should not be minus 1. N should be anything else but not
Minus 1.
And here n is
Minus 2.
So is that a problem?
No.
Fine. Understood? You are looking at it over here. That's not the main thing. We have to look at it on the left hand side. Agreed?
Yes.
This is n. N is not minus 1. N is minus 2. Not a problem. Fine. Okay? So this is how you use this rule. Understood?
Yes.
What to do if n is minus 1? That's the next. Integration of x raised to minus 1 dx. Or which you can also write as integration of 1 dx. Either way, okay, whatever way you want to write, no problem. The base, same as the form there. This is equal to ln x. This is equal to ln x. I can understand if you don't know what is ln, it's fine. Right? ln is actually a kind of logarithm. Have you heard of that? Logarithm? Right? Okay, no problem. Then we'll have to later on cover that also. Okay? Right? Fine. But I will cover logarithm if you ensure that you will not forget it. Right? Because otherwise when we need it next time, maybe after a couple of months, then I don't want you all to be blank once again. Or I leave it for that time when we use logarithm for the first time. Alright? We'll leave it. This is some kind of or something called logarithm. Okay, that's it. I will not go into any further details right now. We'll do it when we use logarithms for the first time. And we will use it. Right? There's no doubt about that. We are definitely going to use logarithms. Okay. So this is what we have. That is, if this is minus 1 here, then first rule is not applicable, but the second rule is applicable. Did you understand?
Yes,
First
sir.
rule is not applicable, but the second. Okay? Let's go further. Integration of dx is x. Integration of dx is x. Clear? Nothing else. Just like that, if someone says what is integration of dt, then it will be dx. Okay? But wait a second, just giving different examples. Now, why is it like that? Let's see. It's actually due to the first rule. if I want to write integration of dx, then I hope you understand that you can say you ate one apple also as you ate an apple. That is, whether you write 1 or not, it means the same thing, right? So whether you write dx or you write 1 dx, it means the same. But this 1 can also be written in this form. X raised to 0 is 1. Correct or not?
Yes.
Sure?
Yes.
Okay. Now, is it like this form?
Yes.
What's the value of n? 0.
Zero.
Can we use this rule?
Yes.
Let's use it. What do you do?
X raised to 1.
It's equal to x raised to 0
1.
plus 1 upon 0 plus 1. 0 plus 1 means 1. So x raised to 1 means x upon 1 means x. Clear?
Yes.
So that's a little proof of this. That integration of dx is x. By similar logic, integration of dt will be t. Just like that, if someone says, what is integration of dv?
dv.
Very good. Understood?
Yes.
Hopefully, you all still remember that integration and differentiation are reverse processes.
Yes.
Okay, that's the basic idea about what integration is. Okay, let's go over to the next one. This is simply now number 4. Keep the constant out. Okay, exactly like it was in differentiation, no change. Nothing new to learn. So here we go. Suppose someone says that there are two things and you want to do the integration of their addition. So for example, some government. So sorry. I had addition subtraction rule if I may ask. Okay, integration of k u dx, where k is a constant. Where k is a constant. Okay. We'll write that of course, but let me tell you what happens here. This is going to be equal to k times integration of u dx. Exactly the same way as it was in differentiation. Take it out. Understood? And this is true if alpha no, if k is a
Constant.
right? So let's take an example of this. Suppose someone will say, what's the integration of 5x raised to 4 dx? What's the integration of 5x raised to 4 dx? Let's use that rule here. So first of all, 5 into x raised to 4. Is 5 a constant?
Yes.
Take it out. So 5 integration x raised to 4 dx. Here can we use the rule number 1?
Yes.
Okay. So what do we get? As the next
X
step, so this is equal to 5 into x raised to, what should I add?
5.
Raised to 5 by 5. Clear or not?
Yes.
Sure?
Yes.
You see, the way to master this formula is very simple. Look at the power, increase the power by 1. So 3 will become 4. So x raised to. And then divide by that power itself. Okay, you see, this is the reverse process of what we had in differentiation. In differentiation, first we were bringing the power down and then we were decreasing the power by 1. Here we are to do opposite. Okay, instead of decreasing the power, first we increase the power by 1. So 3 becomes 4. And then whatever power that is, we don't multiply by that power, we simply divide by that power. So 1. So similarly here, integration of x raised to 4 has become x raised to 5 upon 5. 5 cancel. So final answer is going to be, that's it. Did you get that?
Yes.
Everything?
Yes.
Am I do?
I know.
Okay. Now, once we have got it this way, think about it reverse. What's the differentiation of x raised to 5? 5x raised to 4. So I hope you understood what I was telling you earlier.
Yes.
Differentiation of x raised to 5 is 5x raised to 4. That's why integration of 5x raised to 4 will be x raised to 5. So reverse. Understood?
Yes.
Just like square and square root. Square root of 3 is 9. So square root of 9 is 3. Like that. Got it?
Yes.
Fine. So that is rule number 4, which is keep the constant. Now addition, subtraction. number 5. The addition or subtraction rule. There is really no multiplication or division rule. Okay, it's our chart. Right? There is no multiplication or division rule. There is only addition and subtraction, and that's also exactly the same as it was. Suppose it's addition first of all. Let's talk. So you want to do integration of u plus v. Then that would be separate integration of u and separate integration of v and then add it. Did you understand?
Yes.
That is term-wise integration. If it's minus, then it's minus. If there are 3 terms, then also 3 terms. Did you understand?
Yes.
Extremely simple. One term at a time. But yeah, that's not true in multiplication. Please be careful. No, it's not like you can do it like this. Integration of u v dx is, not like integration of u dx and then multiplied by integration of v dx. No. Okay? Is it fine?
Yes.
Let's take an example. Suppose someone will say the integration of t raised to 2 minus tq plus 1 dt. Then what should I write first of all? Separate all the 3 up. So what will be the first step? Integration t square dt. Okay?
Yes.
Then which sign to put?
Minus.
Minus integration
dq.
dt. Understood?
Yes.
And then plus integration of 1 dt. 1 dt means dt. Okay? So in the next step we'll have the final answer. What will that be? Answer to that. Integration t square dt is? Use the first one. Come on everyone. Who can help me? Raise your hand. What will be integration of t square dt using the first rule? Okay, Sidra. Louder. T3 no kya hai? T cube by 3. Correct. Well done. Sit down. Okay. Next. Integration t cube dt. Raise your hand. Alright, yes, it. Correct. T raised to 4 by 4. Sit down. Correct. And the last one. Integration 1 dt. Understood that?
Yes.
Absolutely sure?
Yes.
Okay. Sometimes you'll have more rules to be used together, right? Multiple rules, not just one. Fine. Largely, this is like differentiate. The rules there. Okay? Right? In some ways, it can be different also. Let's see. Again, first of all, there is nothing like multiplication or division rule over here, so that's one thing which makes it a little bit easier. And we never get those kind of questions in physics also. But next, I just want to ask you: have we written differentiation of sin x?
No.
No, we have not. Are you absolutely sure?
Yes.
Why don't you still check it in your notes where we have written differentiation rules? Rules for differentiation. Do we have d by dx sin x or anything like that? Did I make you write it? I'm just asking. Not that we use it every day or anything, but okay, no problem. So now there's just one rule that I want to mention over here is that if k, which is a constant, is multiplied to x, then in the integration process divide by that constant. Now, frankly, these are not very exact words. Okay. Mathematics teachers will object to this. I would not know why this is wrong, but it will serve the purpose over here, right? Fine. We divide by that constant k. What do I mean by this sentence? As follows. Now, this is like a little bit like the chain rule. Like if you go deeper down in mathematics, it comes from the chain rule itself. But here, is that suppose someone would say, what is integration of root x? Okay. Right? Root means what?
1 by 2.
So this is x raised to half centigrade. Yes or no?
Yes.
What do you think this will become? Do this. Do the integration of x raised to half. Which rule do we use? The one power, correct? Okay. Done. Be careful, the answer should be right. Okay, everyone. First go. Done?
Yes.
Raise your hand. Well done. Yes, love. 1.5. Fraction bubble. X raised to 1.5. X raised to 1.5 upon 1.5. X raised to 1.5 upon 1.5. Can anyone say it in fractions? What you said is probably right. Log 1.5 is okay. Right? Yes, Mantra?
X raised to 3 by 2 upon 3 by 2.
Which is simplify kare
2x raised to 3 by 2 upon 3.
2 x raised to 3 by 2 upon 3. Okay or not okay?
Yes.
Actually, first of all, you will get this. So that's what Love was saying. X raised to 1.5 upon 1.5. But like I said, we generally prefer fractions. So this 2 will be in the numerator now because denominator becomes the numerator. So 2 x raised to 3 by 2 the whole divided by 3. Fine?
Yes.
Okay. Sit down. Good. Well done. Both answers are right of course. So this is what we get. But let's try to use this now here. How so? Suppose instead of this, if we were to do integration of this. Okay. Then what is going on here is, if you look at this carefully, x is multiplied by a constant. Which constant? 5. So what you can do is, you can treat it just like x. So for example, root x, its integration gives you this. Similarly, root 5x, its integration will give you Have you understood this so far? It's not complete. If it's x here, then you get 2 by 3 x raised to 3 by 2. Correct or not?
Yes.
Yes or no?
Yes.
Just like that, if it's root 5x here, then you will get 2 by 3. Extra okay. 2 by 3, 5x raised to 3 by 2. Did you understand?
Yes.
Okay?
Yes.
Instead of x, there is 5x. That's the whole thing. Replace x by 5x. That's all we have done.
Yes.
Okay?
Yes.
But there is one more thing to do, and that is this. So here, what is the constant that was multiplied with x?
5.
5 won't get cancelled because that is in the power. Okay or not?
Yes.
So this is what happens. Clear? This is what this is the answer that we get. I mean, we can simplify it further by taking 5 raised to 3 by 2 and cancelling one of the powers with 5 and all that, but that's not the focus. Okay? Do you understand this?
Yes.
So that's what is the meaning of this. Now, typically we need to use this in sine and cos, especially when we get to chapter 14. Right? Especially when we get to chapter 14. That's why I was asking about sine and cos, that is whether maybe to write the rule for sine or no. Okay, so far we don't need it. Normally in this chapter we won't need it, but later on if we will need it, we'll have to write that. Okay. So that's it about this particular part of the chapter, rules for integration. Now I'm just going to give you a couple of questions for practicing at home. Okay, obviously that would be a good use of your time, right? So it will use all the rules that we have studied so far. Okay, and don't forget what I have been telling you about homework. The more you do it, the more you learn. So this is question 1. Suppose someone will ask you to do integration of the x cubed minus x plus 1. Now a very key thing here is to write it properly. You know what I have seen students do is, even after having done integration, they keep writing integration and they end up doing it 2 or 3 times. What is 3 squared? So the 9 looks. Will you write this 2 further? So this symbol indicates that integration is pending. Pending, that is, you are going to do integration. So the moment you do integration, that is, instead of x cube, you write its integration. That is what? X raised to 4 by 4. Then you don't write this time. Did you get it?
Yes.
એટલે આના પછીનો સ્ટેપ આવો નહીં લખવાનો. You see what is wrong?
Yes.
It's same wrong as it is here. If you can identify.
Yes.
Square कर नाखो तो પછી શું કામ 2 લખવા છે? પછી એકવાર સ્ક્વેર કરો એટલે 3 mono square. You understood what I am saying?
Yes.
So if you leave it like this, then what will happen? You will do integration one more time. પછી ઓય જરા ગ્રેમ કરો આગળ. You understand what's going to happen?
Yes.
So you just do it once. Don't forget that. The moment you do the integration and you use that rule, then you stop writing that sign. Understood? આના જેવું નહીં કરવાનું. પછી 81 નો સ્ક્વેર 3 square equal to શું આવે? 6 by 6 1. એવું થાય ને? And it won't stop ever. So please don't do that. Understood what I said?
Yes.
So write it properly, be careful. The moment you do integration, that's it. Don't put that sign. Don't write dx also. Okay? Here's the other one. Okay, so that's the second one. Right? 3x squared
plus 1
specs. You need specs. अरे आज तो कुछ देखा है उसने? तो क्या ब्रैकेट है? ब्रैकेट what? No, really. I understand that I'm a little bit smaller than what it is here, but it's not illegible. What type? Okay. You know, sometimes when I go and sit on the last bench and I see what I am writing, then I really feel thankful to you all that you don't complain. Whenever I ask, what's I would not love to do, so I right? Okay, fine. So I think, or hopefully 2 questions will be enough. It's still not over yet. We have to write one more rule about integration, but it's more so than a rule. It's like a procedure, right? I'm going to erase this.
Yes, sir.
So far we are dealing with only the math side. How to use this integration in physics, I have not even told you, about it a single letter yet. Okay. So this procedure is, I like to call it pull. Okay. I've given it that kind of name. You are not going to find the name in any books whatsoever. Okay. What is this? It's a short form of put upper limit, then put a minus sign, and then lower limit. How do we do it? Just joking. Okay, so what's all this upper limit and lower limit? Let's see. I will demonstrate this procedure by doing one actual question. If you remember earlier when we were doing differentiation, for example, when we did questions something like, let's say 2t plus 5t square is x and you have to find velocity, then I told you that we have to do dx by dt. Remember that?
Yes.
And then you cannot find by putting the value first. For example, if someone says find velocity at t equal to 5 seconds, then should you directly put t equal to 5 here and here? No. No, of course not. Because if you do that, you get 0 answer and 0 marks. Because once you put values here, everything becomes constant. Then differentiation of a constant will always be 0. Understood?
Yes.
So constant will. Differentiation of a constant is always
0.
Okay? Yeah. So what to do? First, you do the differentiation. You get some expression. For example, it will be 2 plus 10t.
Yes.
And after that you put t equal to 5. Means you should put value not before doing integration but after doing differentiation. Correct or not?
Yes.
Well, we have the same idea in integration. You should not put values before doing integration. You should put them afterwards. Okay? So let's see how. For example, someone would say find out integration of x cube dx from x equal to 2 to 4. This is what is called lower limit and upper limit. I hope you understood why this is called lower limit.
Yes.
Because it's written below. Okay? And this one at the top, so upper limit. Now what this means is, you are going to do this integration procedure from this value of x to this value of x. Again, what we are writing here is a value of x. That is, you can also write this as x equal to 2. Means you have to do this procedure from x equal to 2 to x equal to 4. Can you just write 2 and 4 here? No problem. Can you write x equal to 2, x equal to 4? Yeah, that also. Choose whichever way you want to write. It's fine. Both ways are valid. Understood? Pehla main 2 lekhu and 4 lekhu. Why change karna? Both are fine. This is just a little bit more clear. What this means is we are going to put x equal to 2. What this means is we are going to put
X equal to 4.
Understood? Okay. First of all this is just to be ignored. Use the rule, the one of power. X raised to 3's integration becomes
X raised to 4 over 4.
I was making the mistake that you might make. Integration of this will be x raised to 4 by 4. Understood?
Yes.
There. If the lower and upper limits are mentioned or you are writing there, then compulsorily, again, see very clearly, it's compulsory that you put square bracket. Okay? No other art forms allowed here. Okay? You might be following fashion very nicely, but still, no other art forms are allowed. Clear?
Yes.
Okay. So, and then on the right hand side of this bracket, that's over here, you can write either x equal to 2, x equal to 4 like this, or you can write 2 and 4. Okay, this is one way to write. The other way to write is like this. Understood? Again, two ways to use the same.
Yes.
You can write 2, you can write 4. Or you can write x equal to 2 and x equal to 4. But again, not on the left side, on the right side. All these are mathematical procedures. Nothing to do with physics whatsoever. This clear? It's just that we use this math, so we have to follow that procedure. So that when you read something from a book, it makes sense to you. Right? If I not teach you all these symbols, then you will not understand. For example, if I would not have told you that writing dx by dt means doing differentiation of position with respect to time. You understand what I'm saying? The symbols, we have to learn the symbols. So this is what we are doing. We are learning the symbols. Okay. What to do next? This sentence. First of all, put upper limit. Upper limit, that is 4. X is equal to 4. I'll put it here. It's a coincidence that there are so many 4s. So 4 raised to 4 upon 4. Did you understand?
Yes.
Sure?
Yes.
This x, I put its value as 4. So put upper limit. Done. Then what to write? Minus. Now you put lower limit. 2 raised to 4 upon 4. Raise your hand if you have understood this completely. Okay. Put your hand down. Let me try it one more time just to get nearly 100% here. It's that first of all we put upper limit. So what's the upper limit value? X is equal to 4. That I put here obviously. X ni value x mat muka. Okay, so 4 raised to 4 because x is 4. Got that?
Yes.
And then divide by 4 is already there. So in this whole bracket we are going to put value of x. That's 4. Then compulsorily you put this minus 5. Done. Then you go to lower limit and you put this lower limit and x is placed. 2 raised to 4 upon 4. Understood?
Yes.
Finally, you can do the math. That is 4 raised to 4 upon 4 means 4 raised to 3 minus 2 raised to 4 is 16. Yes or no? Power down again. 2 na power down 2 raised to 0 to 2 raised to 12. Come to 11 to this. 2 raised to 0 to 2 raised to 11. What out is it that tough? No, very simple. एक बार find कर ले तो बढ़िया हो जाएगा. Just multiply by 2, 2, 2 again and again. Okay. Try to memorize these. It helps. Okay. Anyway, 16. 2 raised to 4 is 16. Divided by 4. So 4 cancel here. 4 raised to 3 is 4 cubed. 64. Minus 4. So final answer of this would be 60. Did you understand how to use this procedure? Yes. You might have a question why to use this procedure or where to use this procedure. Next time. Okay. Right now we are just learning math as it is, without learning how to use it in here. So like we try this integration of x minus 1 dx from 1 to 2. Can you do it?
Yes.
First of all, what to do? Ignore the limits. Okay, everyone. Just ignore the limits. That doesn't mean you will not write them, but write it, but ignore it. Just follow the other rules. What are the rules? What should I do here? Addition, subtraction. Yes or no?
Yes.
So what should I write?
Integration
of x dx minus integration of 1 dx or only dx. Define 1 dx or dx. Now there are limits, so please don't forget to write the limit. 1 to 1 to 1 to 2. Integration from 1 to 2. Okay. Usual rules as we have learned so far. Integration of x dx will be x raised to 2 by 2. Clear or not clear?
Yes.
Because x means x raised to 1, correct?
Yes.
So using the rule for power, it shall become x raised to 2 by 2. Got it?
Yes.
Okay?
Yes.
Basically it went like this. X raised to 1 plus 1 upon 1 plus 1. Okay? And then what to do? Put a square bracket like this. Write 1 here, write 2 here. Got it?
Yes.
Now second term, minus. Over here. Integration dx is? What is integration dx? X. Put square brackets. What should I write? 1,
2.
2. Got it?
Yes.
Okay?
Yes.
So this is x square. First of all, which limit to put, upper or lower? Upper. See, every term is individual. Huh? Please ignore this while we are doing this. Every term is individual. So what should I do here?
2 raised to
2 raised to 2 upon 2. This is putting upper limit only. Correct or not?
Yes.
Now we put a minus sign and then we'll put lower limit where an x is placed. So what should I have? 1 raised to 2 upon 2. Understood?
Yes.
Both of these things have come from this only. Alright, one from upper limit and one from lower limit. Second this sign over here, minus. Now you don't need to put square bracket, you can put any kind of bracket, whatever you want. What should I have?
2 minus 1.
First I should put upper limit. What the upper limit? X equal to 2. So put 2. Then minus 1. Understood?
Yes.
And then put 1. Clear or not clear?
Yes.
We got the same square. 2 square is
4
by 2. 2 minus 1 square is
1.
So minus 1 by 2. Over here minus 2 minus 1 is
1.
minus 1. Fine.
Yes.
And what will be the sign answer? Yes, among these some query. Yes, dear. Done.
Yes.
Who else has finished it? Right. Answer is half.
Yes.
1 by 2. Correct or not?
Yes.
Okay.
Yes.
2 minus 1 is 1 and 1 minus 1 by 2 is half. However you do it, answer will be the same. Okay. Is this clear? The full procedure?
Yes.
Okay. Try one more now. Come on. Write only that many steps as necessary. Get back in. Limit fully given. Minus 2. And here, did you do integration of x2? So it will only be, you should not have written that simple, correct? Because you already integrated. Silly mistake. Come on. You did everything right until the last step. Correct. Yes. That's not wrong. Okay. How many of you have finished it now? Rudra, what's your answer? 32. Who agrees? You are so enthusiastic. You didn't find your mistake? Okay. Minus 2 raised to 4 is not minus 16. Minus 2 raised to 4 is plus 6. Is mistake? Good, 32. Sit down. The answer is 0. Okay, the answer is 0. Let's see how. So first step, again, you see I'm laying emphasis on writing it. Like I said, it's a little difficult to learn how to write at first. Kick the constant out. Okay or not okay?
Yes.
And if limits are there, you should never forget the limits, because without that it would be wrong. First step clear?
Yes.
Not just what I have done, but how I am writing. That's also clear?
Yes.
Okay, there. Integration x cube dx
X
raised to 4 by 4. And now you have to write this in which kind of bracket?
Square.
Ava. Okay. Right. Now 4. Actually you will, you know. Correct. याद रहे. So minus 2 and 2. Actually you can take this 4 outside also, because 4 is always 4. Whether you put x equal to 2 or minus 2, value of 4 will always remain 4. So that's like we take constants out. You can do that. Understood?
Yes.
Because it is individual. But even if you don't do it, answer is not wrong. So here. Now I'm going to put limit. So what should I write? First of all, upper limit. So 2 is to 4. Upon 4. Minus 2 raised to 4 upon 4. Got that?
Yes.
So 2 raised to 4 is 16
16.
by 4. Minus 16 by 4. So these are same, of course. So answer will be 0. Understood?
Yes.
Outside 4. 16.
4 into 0. अरे कट में 4 into 0 होता है. Become 10 less. Okay. So answer will be 0. Got it?
Yes.
Bracket is 0. So 4 into 0. But आप कट कर सकते क्या मानो नहीं? पहले तो आंसर भूल जाओ.
Sir, God said no chance. 4.
और एक b जगह कटती जाए. 4 अंदर मल्टीप्लाई करें तो ये कटती जाएगी, ये कटती. Okay, so this is a couple of homework questions for you. Number 3, they already have questions.
Yes.
Those are without limit, and now this is with limit. Okay. क्यूब रूट આવે તો તમને મજા પડી જાય એટલે જ આપું છું. Sorry, કેવા સમ કે કરે એમાં કઈ ટર્મમાં પ્રોબ્લેમ થાય કરતો p²/2 ને. ઓકે ચાલો કરાવી દો એમાં. Have a look here. Suppose someone would ask you to do integration of this. કરો આના જેવું છે ને બરાબર ને. સેકન્ડ ટર્મ એ છે ને કઈ. ઓકે so here is 5 a constant or not?
Yes.
So you can take it out. What should I write? How logo?
No.
Is this correct?
No.
What should I write? 5. Understood?
Yes.
Because 5 is individual, so you take 5 outside, so 1/5. What is?
Yes.
Right? Okay, so hopefully everyone has noted down the questions. So that's it for today. Alright? Yes. Turn it off.